I'd like to get started first by noting that there is a Google Doc I've left in the chat room that everybody can edit to add questions to pitch at particular presenters, and you get a chance to actually ask those questions yourself if audio and everything is working. And but what I'd mainly like to do, Handy can give the introduction to the workshop, but I just want to put in a plug-in for the organizers of this and how much I've appreciated working with them to deliver all of this to you. So Lee Carmody, Melissa Handel, Lauren Chen, Lynn Shermel, Duccio Calveri, Tarini Naravani, and Robert Warren and Jessica Singer. You've all been a real help. If you're on the call right now, straight to you. Thanks so much for helping organize these 4 sessions and reviewing all the papers and the suggestions for actually breaking this up into 2.5-hour chunks of time. It's all worked out so well so far. And so I really appreciate your help and kudos to you. So over to Handy to introduce the session.
Thank you, Damien. And I echo Damien. Thank you all to the organizing committee for this really educating event. This was really helpful for me, and I hope everyone to see all the different aspects of the food ontologies realm. I would like to introduce myself and thank you everyone for being here today. I am Hande Kuchuk-Miginti, and my research has been about ontologies and how they can be built concordantly so they can work together and they can be applied to fair data, artificial intelligence, and machine learning applications for better understanding and analyzing this data. I am a computer scientist by training, but I've always worked in multidisciplinary teams. I really love that. Currently, I'm a research scientist at Collaborative Drug Discovery, and at CDD, we have various projects related to fair data, and one of them is Bioharmony project. And with that, we built an annotator that uses different ontologies in the background and machine learning methods to help annotate plain text that is human readable and make it machine ready. It's currently focusing on preclinical and postclinical data, but it's a versatile tool that can be applied to any data. So today's presentations are all about tools and methods. I am really excited to hear all of them. And we are going to start with Dr. Ian Horrocks. The presentations are going to be about 10 minutes long. So far, I think everybody knows that they're going to be on time. But if something happens, I will be warning them in about when they have about 2 minutes left. So I'd like to briefly introduce Dr. Horrocks before he starts. He's a full professor at Oxford University, Department of Computer Science, and he's a visiting professor in the Department of Informatics at the University of Oslo. His research interests include logic-based knowledge representation and reasoning, semantic technologies, and he's an author of the OIL and DML plus OIL and OWL languages. And he was also chairing the session that standardized OWL 2. And he developed many algorithms and standards and optimization techniques and reasoning systems that underpin OWL applications. If you use many of the reasoners that are in Protégé, you've used his work. And he is a fellow of the Royal Society, a member of Academia Europaea, a fellow of the European Association for Artificial Intelligence, and a fellow of the British Computer Society. I, for one, am really looking forward to his talk today. Dr. Horrocks is going to talk about how we might be able to save much valuable ontology engineer and domain expert time if we can use machines to help us identify some missing information errors in the large ontologies. Without further ado, Dr. Horrocks.
Okay, thanks very much, Handy, for the kind introduction. I'll share my screen now. I think that's the way to go. Let me just try to find the actual presentation. Okay, let's see if this is going to work. So you're seeing that?
Yes, we are.
Yes.
Good. Okay, then I'll get straight into it. So this, as Handy just mentioned, is a talk about tool support for ontology design and quality assurance. It's joint work with Jiaoyan Chen, who's a colleague at Oxford, and Jaehun Lee from Samsung Electronics. So yeah, we all know ontology design and development is a really hard problem, and it requires input not only from domain experts, but also from ontologists, people who know how to design ontologies. And in spite of the fact that it's such a hard problem and that ontologies are really being more and more widely used these days, not just in areas like this one, but even quite extensively in industry these days, tool support's still quite limited and hasn't progressed all that much in recent years. I mean, Protégé is still by far the most widely used tool, and I mean, kudos to them for the incredible amount of work they put into developing and maintaining Protégé, which we'd really be lost without. But I mean, there's a limit to what Protégé can do for supporting correct design. It ensures, of course, the syntax is correct, but it doesn't really do a lot to support the actual, you know, good design of ontologies. And as well as getting the basic design right, the whole sort of QA process is particularly challenging. I mean, typically, really, that just involves checking by the people who are building the ontology as they go along. You know, maybe they have some sort of methodology for doing that, but it's really difficult. We do have reasoning support, and that is extremely useful, but that's also quite limited in what it can do for us. And the reasons for that, on the one hand, are that OWL and other first order ontology languages that are mainly what people are using are monotonic. And what that means is that taking information away won't ever cause more entailments. So if you miss something out, that won't lead to an inconsistency. On the other hand, ontologies are typically highly under-constrained. So for example, it's quite often the case that you see few, if any, disjointness statements between classes. And this general under-constrainedness means that also often it's the case that even saying incorrect things in the ontology won't lead to inconsistencies either. So, you know, reasoning it's good, but it has its limitations where QA is concerned in particular. So with all this in mind, we've been thinking about tool support for ontology development in general, and we've been doing a lot of things with machine learning and other statistical approaches. But in this case, I'm going to tell you something about some work we did specifically addressing this ontology QA problem. And the basic idea is, why not use another ontology as a kind of surrogate for domain experts? So of course we could employ a kind of huge team of domain experts to crawl all over our ontology and check everything, but that's pretty expensive. So maybe we could try just using another ontology to do that. And the basic idea is we take our ontology that we want to QA and we select another ontology that covers a similar or overlapping domain. Then we use one of the many available alignment tools to align O1 and O2. And basically what that means is we can then use O2 to sort of check the modeling of O1 by basically comparing how things are modeled in O1 and O2. And then, well, some of our work, actually, we've been exploring automated correction, but in this work so far, we're only really envisaging the idea of reporting suspicious looking things, differences in the modeling back to human experts, so they can then focus their valuable time on looking at those things. So just to show you in a bit more detail how that would work, we did a little case study using HELIS and FoodOn. So as many of you probably know, HELIS is, I think it stands for the Healthy Lifestyle Ontology, something like that anyway. And it covers food, health, and other such things. So it has quite a good overlap with FoodOn. We used our log map tool to do the alignment, but basically you could use any alignment tool that you like. And what this tool does is it identifies mappings between the two ontologies. And basically a mapping is actually an axiom that says, that's an equivalence axiom saying that a class in FoodOn is equivalent to a class in HELIS. I mean, this doesn't make it be absolutely true because these mapping tools are not perfect, but hopefully if they're reasonable, it does, you know, a reasonable job. And in any case, we don't care if everything is completely correct, because our goal is just to sort of feed back to the human experts some areas that they might look at in more detail. So then how do we use these mappings to compare the two ontologies? So the way that works is we use a reasoner, Hermit in this case, to classify FoodOn on its own and compute the subclass hierarchy of FoodOn. And then we do the same thing with the ontology we get by unioning together FoodOn, HELIS, and the mappings. So note the mappings are axioms just like any other axioms in the ontology. So actually we can just concatenate those three things together and we still have an ontology, and we can classify that using Hermit. And then we look for cases where we see a subsumption relationship between classes that holds in this combined ontology, but that doesn't hold if we only consider FoodOn on its own. So this sort of suggests that then there's some difference in the modeling between HELIS and FoodOn. So some examples of what we got out of that process: the log map computed several hundred mappings. And when we then did this modeling comparison process, we actually got about 500 examples of pairs of concepts that were differently classified in FoodOn than in the union ontology. And a couple of examples of mappings were that logmap reckoned that HELIS soy products is the same thing as FoodOn soybean food product, and that HELIS soy milk is the same thing as FoodOn soybean milk. And as I say, there were several hundred of these mappings. And then interesting pairs of classes that were identified using this process where the modeling seems to differ somewhat are, for example, well, soybean milk. In FoodOn, it's not the case that soybean milk is a subclass of soybean food product, but that does hold if we use the combined ontologies. And actually, this seems to be somewhat problematical in the case of FoodOn. Intuitively, I would certainly expect soybean milk to be a subclass of soybean food product. And that could actually be pretty important if we were looking to use FoodOn to alert people to possible allergy issues and so on. Another example was maitake mushroom, which isn't a mushroom vegetable food product in FoodOn alone, but it is if we use the union ontology. And basically there seems to be some inconsistency with the way individual mushroom types are classified in FoodOn. Some of them are classified in the kind of food source hierarchy, and some of them are classified in the food product hierarchy. And finally, we noticed that there were a whole bunch of suspicious things around vitamins. And when we look closely, we discover that FoodOn has multiple vitamin hierarchies with different spellings and capitalizations. So there's definitely something going on there. So I think I'm roughly at the end of the 10 minutes. So just to sum up, seems a promising idea, but there's quite a bit we would need to do in future to make this be really usable. At the moment, it's just pretty much of a lash up and we need to build a proper tool. There are a few technical issues. Explanation would be important. So when we got these suspicious classes back, it actually took me really ages to sort of look at the different ontologies in Protégé and try and figure out what the hell was going on. And also vitamins, for example, threw up numerous errors, and it would be good to sort of cluster them together and just say, look, you know, there's something going on in the vitamin space. And of course, we would need to evaluate on a wider range of ontologies before we could declare that it's really useful. So I think I'm done. As I understand the process, we save questions for the end of the session, right?
That is correct. Thank you so much for your...
Okay, so I'm done and I'll hang on and answer any questions at the end.
Thank you so much. We appreciate that. It was very interesting. I was very impressed by this kind of a semi-automated method that ultimately gives the power to the domain experts, but then helps them hopefully and saves them time. That was great. Thank you. Like Dr. Horrocks mentioned, the questions will be at the end. The link to the document for you to write down your questions is in the chat. And please let me know if you have problems reaching it. And we will continue our session today with Dr. Patrice Buche. I hope I'm pronouncing this right. He's a research engineer in the computer science department with the INRA. All right. And thank you for taking over the screen. And he is the head of the knowledge engineering group at the IATE research unit in Montpellier. Patrice's research interests are data and knowledge integration guided by ontologies for decision support purposes. Main applications concern food and bioproducts, especially the new generation of biosource food packaging. He'll be presenting a new alignment method today, and it's based on synthetic and semantic approaches, and we'll talk about a real use case that involves 2 food composition databases. I'm really looking forward to hearing Dr. Buche. Is this the right way to pronounce your name? I'm so sorry.
Yes, Patrice Buche, yes.
Buche.
Nice
Okay.
pronunciation.
Okay.
Thank you for your kind introduction. I will present a new alignment method based on FoodOn as a pivot ontology. This work comes from a project with some industrial partners in France. And the context is a nutritional score assessment of a recipe. And the question we wanted to deal with is how to deal with missing information for a given ingredient in a given food composition database. Like, for instance, you don't have information about iron, vitamin B12, things like that. And the possible solution we have worked on is to retrieve missing information from a similar ingredient from another food composition database that we call FCDB in my slides. And how do you intend to do that? We use FoodOn as pivot to link the food product vocabularies used in various FCDBs, and in my talk we have made some assessment with SQL and USDA. And we also use Langwall as background knowledge, and we use both sources of information to determine for each product of FCDB the closest product and family in FoodOn. Here in this slide, you can see a screenshot of a prototype we call the MultiDB Explorer. In this web app, we integrated 7 FCDBs, including SQL and USDA. And you can see here that we can query this integrated database using a name of the food product. Here I put a French term, courgette purée. And in the bottom of the slide, you can see that we found one result coming from the French database, namely SQL. If you click on this food product before you come to this new screen, where you can see that we have the lingual description of this food, courgette puree, which is a set of facets expressed in the lingual standardized vocabulary. And here we see that the courgette puree is fully heat treated. It is one of the facets. Here we suppose that we have a missing information in the SQL database, for instance, about vitamin C. And what you will see is that thanks to the algorithm we have developed, first we could put this courgette puree in the FoodOn family squash vegetable food product, in which you can also see that other terms, other fruits coming from USDA have also been put. For instance, if we click on the squash winter corn cooked, boiled, mashed without salt, then you come to this screen, and here you can find the detailed composition, nutritional composition of this food. And here we have the value for vitamin C, which is 6.5 milligram per 100 gram. It's what now I will give you some details about this alignment method. What we want to do is to find the closest product and family in FoodOn for each product of a given FCDB. And as you said, the approach is to combine two kinds of information. First, syntactic information, product name, label, in English, and also the semantic description of the food product using lingual facets, as I showed you before on an example. And what we do is to compute a similarity score, which is an aggregation of two scores, a semantic one. We compute using the comparison between lingual facets and a syntactic score, comparing the labels themselves. Here, just a quick information on the way we compute the semantic score. In fact, this semantic measure is a weighted sum of similarities between each facet of both products we compare, one from the FCDB and the other one from FoodOn. If the two facets are the same, we put the similarity to 1, and if two facets which are compared are different, the similarity depends on the length of the shortest path between both facets in the lingual hierarchy. Here in this slide, just a little example to explain the intuition. And we want to compare the product P with products P1 and P2. You see that for facet A, it's the same thing. Similarity is 1, but for facet B, we have different concepts. And here, our similarity measure will say that similarity between P and P1 is greater than similarity between P and P2, because B11 is closest in the path to B12 compared to B21. Here, it is a complete example. Here, what we want to do is to find correspondences in FoodOn for the SQL product, the cooked pork shoulder. Therefore, here I presented on the right part of the screen an excerpt of FoodOn hierarchy, and we have in red the similarities, the score associated, the similarity score associated with the different terms of FoodOn. And you see here that the greatest score is for pork shoulder cooked curd. And after we determine the closest family in FoodOn as being the family of the closest product. Now I'm coming back to the use case. I said that what we want to do is to be able to find to replace missing information for a given ingredient, reusing information which is available in another database for a similar ingredient. Therefore, we did this work for SQL and USDA. And here, the method we used is first to align a SQL food concept and USDA food concept on FoodOn, and after by transitivity to determine automatically alignment between SQL food products and USDA ones. And the use case was to find in USDA database values associated with nutrients, vitamin C, B12, and iron, when they are not known in SQL for a given food. We did that on a golden standard of 99 SQL terms, for which we at least one of the values associated with the free nutrients is not known in SQL, and for which at least one similar term can be found in USDA. And here you have the results. We found 76 alignments which have been considered relevant of the 99. And for those 76 relevant alignments, we could find 91% of the known values in SQL, which has been enriched by values from USDA, and 96 of known values in SQL, which have been completed by values from USDA. Then as a conclusion, this work is currently submitted to a journal, EGIS, and also this prototype multi-DB Explorer is an extension of Food Explorer from Eurofear with a new functionality, I mean, similar food search. After the project, which is now finished, the Multilab French project, we have discussion with one of the partners, the ACT System, who is interested to reuse this work. And also we envisage other possible discussion and valorization with the French nutritional agency ANSES, Eurofear, and also in-high food platforms. Also, we are interested in reusing the data we have integrated in a multi-DB Explorer for modeling for predictions in order to define prediction models of O2, CO2 solubility in food. As I mentioned, I am interested in tools in order to design new food packaging, and it will be useful for that. And also concerning the alignment method, it could of course be enhanced. And another question we are interested in is to see how we can learn from alignment correction done by annotators, and also to see if it's possible to replace the background knowledge language by FoodX2. Thank you very much for your attention.
Thank you so much. This was very interesting, and I appreciate you being on time as well. So again, the questions are going to be in the document. I will send the link again in a minute. We will continue with the same research in it, I think, with Dr. Liliana Ibanescu. Liliana is an assistant professor in computer science at Agro-Paris Tech in the Paris Institute of Technology for Life and Environmental Sciences. She is also a member of the research team at RNAE, the French National Institute for Agriculture and Environment. Liliana is also co-head of the French Research Network on Integration of Heterogeneous Data and Sources and Ontologies. Her research interests are building ontologies for different domains and using semantic web standards and W3C recommendations to do so. Liliana is currently participating in the process of building the core ontology for the process and observation ontology, PO2, that allows the modeling of both transformation processes and experimental observations. Our love for trying to model the processes is how I met Liliana earlier. Her paper published last year in the International Dairy Journal and shows the benefits of using the core process and observation ontology for data integration, aiming to evaluate sustainability challenges in cheese production. Take it away, Liliana.
Thank you. Can you hear me?
Yes, we can hear you fine. Thank you.
Okay, so my talk is about the joint work between 3 teams from INRAE, the same as in the talk just before. INRAE is the French National Institute for Agriculture, Food and Environment, and Juliette Dibie and myself are teachers at a French university which is named AgroParisTech. Our story started 5 years ago when we were involved in a project aiming to formulate a well-balanced product with acceptable qualities using eco-friendly production processes. INRAE experts were involved and available data were about dairy gels. There were mainly research data on real and model cheeses. Here is an example of a question we want to be able to answer. Which hard cheese sample has the highest value for taste intensity and aroma intensity? 3 years ago, we were involved in another project, the one that Patrice presented just before, aiming to produce nutritional fact labels for manufactured meat product. An industrial partner, Solina, was involved. INRAE experts and available data were about sausage making. Here's an example of a question where we wanted to be able to answer: how many knacks have an adhesiveness higher than 2.0? So our solution proposed during this project is a workflow for data representation and integration. So first, we represent knowledge using a domain ontology, which specialize and extend the core ontology. We annotate data with concept from the domain ontology, and we store data in a repository. We build 2 dedicated tools, PO2 Manager and Spock. This workflow is implemented using semantic web technology.
Excuse me, Liliana, we don't see your slides. It's not.
Why?
It is only on the first one. It is still fixed on the first one.
Oh, that's strange. Because it's just a moment. I don't know what to do.
Would you like to stop sharing and then reshare, perhaps?
I don't know what it means.
Okay. Do you want to start sharing again?
Share again, okay. Do you see it?
We cannot see your screen. We see you.
Okay.
And the beautiful sunflower in the background.
Let's try other thing. Let's try to share desktop. No, just.
There we go. We got it.
Is it okay?
Yes.
I can. Okay.
Okay.
So.
Just take your time. So if you want to go.
Are you?
Back a little bit.
Do you need that I came back? I think it was just a story. If you can, if you are on the 4th slide, I think it's okay. Do you see the 4th one?
Yes, that's the one.
Okay.
Yep.
Okay, sorry.
If you want to backtrack a little bit, you're more than welcome to.
Absolutely.
I can do this if you want. So let's see if it works. So I'm back to the 2nd slide. I hope it's okay. So the slide was to present one of our projects that give the idea to do what we have done in the project. And what is interesting here is that we have competency questions that need to explore data for very different domains in cheese production, sensory perception, and life cycle analysis. The second project was about produce nutrition fact labels for manufactured meat products. And this is the same project that presented Patrice just before about finding missing information about nutrient in food. And this is my example in the presentation will concern this project. The data we have is about sausage making. And the solution we propose that is available that is suited for all both of the project is this integrated workflow where I want to show what we have done. So first, we have our solution is the following. We have a domain ontology that specialize and extend the core ontology. We annotate data with the domain from this, with the concept for this domain ontology, and we store it in a repository. And for doing this, we needed to build two dedicated tools that I will present today, PO2 Manager and Spock. And all this workflow is implemented using semantic web technologies, RDF, OWL, and Spark. So I will start with a very short presentation about the core ontology. Then I will present our tools. So let's start with an overview of the process and observation core ontology. We identified the following representation needs. We want to represent transformation processes or itineraries having a succession of steps. We need to represent components or ingredients as input and outputs of steps. We want to represent the material involved in the transformation process. And finally, observation about all of this. Here you have an excerpt of the PO2 ontology. It is based on standards like BFO, SOSA, and time ontology. The concept in blue concerns the representation of steps and processes. The concepts in green are about components or ingredients. The orange concepts is about concerns transfer observation, and the concepts in gray are about numerical or qualitative results of an observation. Our ontology is available on AgroPortal and has 67 concepts and 79 relations. Let's move to the second part. The first objective of our tool, PO2 Manager, is to assist domain experts in building the domain ontology by extending the core ontology and reusing semantic resources. The searching functionality allows one to type the name of a concept. Here is sausage seasoning. I hope you don't hear my neighbors. Sausage seasoning, to select some existing resources. The result of the search is the results of the search are displayed in a table. And if the user finds a useful concept, like for instance, sausage seasoning from FoodOn, and wants to reuse in his ontology, our tool helps in adding this concept in the hierarchy and stores as an exact match the information about the reused concept, a FoodOn concept in this case. The second objective of our tool, PO2 Manager, is to annotate data with concepts from the domain ontology and to store them into a database. Let's take the example of the sausage making itinerary. This is its description as a flowchart in French, as given by our industrial partner. The first yellow box describes the ingredients, the input of the whole process. The steps are in blue, and the green boxes are observation to be done during the process. Let's see how it looks like once how this itinerary looks like once it has been represented in PO2 Manager. The 5 steps of the sausage making itinerary are displayed on the right. And this is the first itinerary in the list of stored itinerary. Which, when choosing the step here, food cartridge process on the left, you can see the material used during the step. In this case, it is a cutter, and all the ingredients are named here component with the quantity and the unit for each one. When choosing the step controlled atmosphere storage process, there are observations for texture. And in this case, we have 3 observations with numerical value and units. We built a second tool, which is Spock, for querying data stored in the repository. It proposed a set of predefined Sparkle queries for users who don't know Sparkle, and there is an advanced mode for writing complex Sparkle queries. Let's take the example I give at the beginning of my talk. How many knacks have an adhesiveness value higher than 2.0? Using the Spock interface, we have first to choose a data set, then to filter on the steps, then to filter the transformation process, then filter on the step, but it's not the case in this example. And finally, you filter on the property, in this case is adhesiveness. And once you execute the form, the result will be displayed in a table. Here we have 2 knacks with an adhesiveness value greater than 2.0. The conclusion of my talk is that we propose the core ontology for representing processes, components, and observation, and we specialize it in 3 different domains. We built a repository implemented in GraphDB having 5.5 million RDF triples and storing almost 1,000 itineraries. Our first dedicated tool, PO2 Manager, assists domain experts in building domain ontology. It is a standalone application implemented in Java. And finally, we build a web application Spock for querying data. Our further work, the first issue is about the task of integration. We will continue to store and query itineraries from the Transform INRAE department specialized in food, bioproducts, and waste, but also from food industry. The second direction for future work is to continue to explore the use of the ontology to learn probabilistic relational models and to discover causal relation. And we will continue to explore how to use our data in decision support tools by studying the impact of process variables on the quality of the end products. Some published results about how to compute indicators or to formulate well-balanced food products. And thank you for your attention.
Thank you, Liliana. And I'm sorry that we had a slight technical difficulty at the beginning, but I'm glad it was not a big problem. Thank you again. This was very interesting. I'm actually looking forward to exploring these tools that you presented a little bit more myself. Next up is Gurinder Gosal. Gurinder is a researcher, an academician, and computer professional with more than 18 years of experience. He's earned his master's and PhD in computer science. For the last 2 years, he's been working at the SEO lab at UBC. He's been contributing as an NLP and semantic technology researcher there and leading the LexMapper project for developing a rule-based text mining tool that parses the short free text sample metadata. It maps the identified entities to terms from selected domain ontologies and classify these as per institution-specific classification schemas. Gurinder is also leading a task to provide NLP-based harmonization tools for by focusing on the narrative contents. He has previously developed a very large ontology, Prokino, at University of Georgia in the United States. And today, he will be talking more about the LexMapper project. Gurinder, if you're ready, we're ready too, I think.
Thanks, and I'm audible?
Yes.
Thanks. Hello, everyone. So today I will be, as I told, I will be presenting about LexMapper. So LexMapper is a rule-based anti-leaking and ontology-driven classification tool that is actually focusing on specifically on the short free text entities or phrases, whatever you call them. A little background about the LexMapper. LexMapper was built to address the needs of our in-house FoodOn and Jaehun ontology users. When they wanted some kind of a tool, so for their application, they can link their data or text to ontology terms. And the pressing need came when US FDA's genome tracker, they wanted to use our ontologies for standardizing the short phrases which were describing the food pathogen source data. They wanted to use the ontology terms in their foodborne disease surveillance and outbreak investigations, which they do. And afterwards, LexMapper has been also further extended to provide the ontology-driven classification mechanism also for the specimen data. Again, we were using the genome tracker dataset and following a IFSA classification schema. So how we approached developing LexMapper, we looked at the biosample data sets primarily consisting of NCBI biosamples, and looked at what are the challenges in mapping those to the ontology terms. And we found that like there are very specific challenges in the case of short phrases. And also our domain was having a very focused semantic domain. The challenges, when we talk about the challenges, you know, like in the case of the biomedical domain, there are well-reported challenges regarding the text mining are there. But in the case of short phrases, we found that like there are grammatical inaccuracies. For example, inconsistent use of case, inconsistent use of punctuations, arbitrary ordering of the tokens, loose formation, and frequent use of abbreviations. And if the abbreviations are used, also they are not standard abbreviations. Also, the context was kind of missing or ambiguous because surrounding text was not there. And if we look at the domain-specific challenges in our biosample domain, the challenge was also like there is a non-English usage of food names, for example, for representing those food descriptions. So we came up, we thought like a rule-based approach, having well-designed or defined manually rules and having some wide-ranging lexical resources, that should work well. And eventually it worked well in our case for the application we built. And afterwards, like I told you, LexMapper has been equipped with the functionality to classify the phrases about as per the third-party classification schemas. And we represent the third-party classes or categories characterized in terms of the ontology high-level classes, which we call them buckets. And we use those buckets actually to classify into third-party categories. I will show you that in one of my slides. So for this particular application about the biosample domain, we use these sources like we mapped the terms to two key underlying ontologies, FoodOn and Jaehun, which were representing the biosample domain, food biosample domain especially. And of course, they contain also the terms from relevant terms from the other ontologies imported from Envo, Uberon, NCBI Texan, for example. And we also locally created domain-specific lookup tables for abbreviation, normalization, spelling correction, additional synonyms. Of course, the synonyms are in the ontologies. Ideally, those are in the synonym in the ontologies, but we found that like many synonyms are missing in the ontologies. So if we could use those synonyms also to enable the mapping, so we have this lookup table also there for our particular domain. And of course, the non-English food terms translation lookup table was also there. So this, if we want to look at high-level architecture of LexMapper, there are two key components here, the mapping pipeline and the classification pipeline. And when we input the short phrase to the mapping pipeline, it goes through processing through successive phases, pre-processing phase, normalization phase, and term mapping phase, and before being mapped to the ontology terms. In the pre-processing phase, for example, we do the data cleaning, do the treatment for the case or the punctuation, spelling correction. So these kind of things are done in the pre-processing phase. And the pre-processed phrase is then input to the normalization phase, in which we do the normalization, if applicable, for the abbreviations, for the non-English names. And these pre-processed and normalized phrases, actually, we can say them as the clean phrases. So these are also stored separately if user want to use that, because sometimes user want to store the clean phrases along with the original phrases or original data. So that is clean phrases. So now the clean phrases are then fed into the term mapping phase, in which different rules are applied to make the mapping possible. And in that case, if no direct mapping is there, then we of course use the synonym substitutions and other things like adding fixes, and so many other rules are there to make the mapping possible. And once we have the mapped phrases to the ontology terms, it can be the basis of many potential applications. And one application which we did was to do the ontology-driven classification. And in that case, as I told you earlier, we characterize the third-party categories in terms of the ontology buckets, which are the ontology classes. And with the help of those, we actually get the third-party categories classified for those phrases. And on the top of that, we also have the classification refinement rules, which according to the needs, very specific needs of the user, we have to further refine those categories which have been classified. One example is in case of genome takeover, if you have a clinical research, for example, and you have an animal involved in that, then it has to be classified as the veterinary clinical research. So in that way, we use the this refinement rules further. And this is how the classification is done. So here's one example. In ideal world, it should be the ontology classes should represent the classes which we want to classify. But we know that the third parties have very different requirements than how the ontology is being structured, or the hierarchy of the ontology is there. So in that case, we see that the subtropical fruit, which is a third party class, so it might be consisting of multiple ontology branches or classes, which are consisting of this subtropical fruit. And the phrase can map at any level of this particular branch, and it will traverse back to the ontology buckets. And those buckets, so we will drive the third-party class from those buckets.
2 minutes.
Okay. So if we want to look at the results, this is the snapshot slide, which is showing you the results here. So here, the different rules are in play. You can see that in this column. And on the right side column, you see the classification that is being done. So you can see the punctuation treatment, change of case. These are simple example, but you have synonym substitution, that is how stool is mapped to feces, for example. And the spelling corrections are there. So you see the frozen here in that case is being normalized before being mapped. And you have the suffix addition, for example. Also, the permutation of tokens in the input. We are also taking care of how the ontology labels are have the problems or inconsistencies. So we take care of that also. And non-English substitution, you see that. And in majority of the cases, actually, it's not a one rule. Actually, it's multiple rules which are needed to enable the mapping of the phrase to the ontology terms. So LexMapper is available in this particular link is for GitHub, and Anaconda is there. We also have a simple graphical user interface, but I have not put the link there because the server is being moved. So we will put it there afterwards, maybe. And scalability. So user asks, most of the time, user asks whether LexMapper is just for the biospecimen domain, or is scalable to the other domains. So the answer is yes. We have been testing it for the COVID and Seneca projects actually. And you can select your user-specific ontologies, for example, here. there is a tutorial on that. It means it's not a FoodOn or JNAP. You can have your set of ontologies and the part of ontologies. And customization, of course, can be done for the lookup tables, because these are domain-specific, biosample domain-specific tables. You can replace them with fewer ones, or augment with them with the additional values. And you can also customize like which stop words to retain or eliminate, which punctuation is to remove, or you want that punctuation to be retained. And singularization, for example, you don't want to, you have exception rules for that, like you don't want to singularize these words or tokens because domain-specific requirements are such that you don't want to singularize those. And there are other rules which you can customize. And I thank my team members, Damien, Emma, Ivan, and my principal investigator, William. So these are the funding supports we are getting from the different agencies. And I will be taking the questions after the session is over. Thanks for listening.
Thank you, Gurinder. This was really interesting, and I don't really envy you looking at all that inconsistent data entries. That must be painful. I would like to remind the audience one more time about our document for questions. And our final presentation before we take a virtual coffee break is from Dr. Usaki Chatterjee. And after that, like I said, we're going to have a brief coffee break and then come back to discuss the answers to the questions and further discussion. Dr. Chatterjee is a postdoctoral teaching associate at the School of Computer Science and Informatics at Cardiff University. Prior to joining to Cardiff, she was a senior research fellow at Indian Statistical Institute in Bangalore, India. Her main area of research lies broadly in the semantic web, knowledge representation and reuse, domain modeling, information seeking and searching. During her doctoral tenure, she worked on ontology reuse, where she investigated that people involved in several streams of professional pertaining to food industries. Her team was awarded a grant by the Department of Science and Technology in India to visit University of Trento in Italy. There she was collaborating the ITPAR project. And she's an active participant in other projects with the No Dive group at University of Trento. And she's presently working on 2 specific domains, recipe and ingredients. I think this presentation will be a great segue to attorney's notes about her experiment. Dr. Chatterjee, take us home, please.
I'm trying to share my slide, yeah. But it says your screen sharing is paused.
Okay, let me stop you and then you can restart. How about that?
Okay.
Okay, would you try again? Still the same. Okay. In the interest of time, would you like me to run your slides for you?
Oh yes, that would be fine for me.
Okay. Yes.
Okay.
Okay, give me 1 second. Okay. It's opening. All right. I'll stop your screen and I will share mine. All right, you stopped already. Perfect. Okay. Share my screen. Okay, here we are. Let me see. Can everyone see this?
Yep.
All right, here we go. Let me do this slideshow. Play from the start. Okay, you can just go ahead and let me know when you need me to change the slide.
Sure, thanks, Andy. So just I'll discuss. This is an ongoing project. Can you hear me?
Yes, we can hear you fine.
And so this is one of the most important yet under-researched factors is the role of diet to address depression in elderly. Next slide, please. So we have next slide. Thank you. So these are the so we have collaborated. There are academicians. Previous slide, please, Andy. Council members, NHS involved in this project. And next slide. So as I said, the context which is related to a predominant chronic illness, which is depression. And next slide, please. So particularly in UK, all over the world as well, the age population is aging rapidly, and UK has a record number of adults suffering from chronic disease, and which is adding to overall global burden. And we are trying to address, we academics and the NHS and the council, we are working hand in hand to address this particular issue. Now, next slide, please. So there are several approaches to address depression. Of course, medication is one of them. There are other recommendations like leisure, entertainment, exercise. Next slide, please. And of course, food. So medical practitioners, dietitians, nutritionists, they tend to recommend food as one of the means by which this particular chronic illness can be addressed. Next slide, please. And traditionally, there are a list of food items that they tend to prescribe, and I have just provided some of them. But the real challenge comes when we go out of the traditional prescription. Next slide, please. So the problem is that diet and food preferences, they differ significantly, as there are several factors, ethnographic factors, which affect population and influence food choice. And we, in this particular project, we are trying to address this problem. And next slide, please. And we try to address these three aspects: religion, culture, and socioeconomic factors. And we try to emphasize on these factors when we try and deal with depression, geriatric depression. So most of us will agree that every religion has different food. There is a heavy influence in the choice of food consumed in society. For instance, Hindu and Buddhist, the religion, they do not welcome consumption of pork and beef. So if you visit a McDonald's in India, you would not get a beef burger. Only chicken burgers are there. So also, needless to say, there is a influence of culture on food, and also the socio-economic aspect plays a huge role. Me coming from a developing country, I understand this aspect. So a prescription, so-called as an oily fish salmon, is not consumed by every household. So next slide, please. So this is the background of our work, and today I will be presenting the approach that we have undertaken to build the ontology, which is a principled analytical approach to build a food ontology for elderly. Next slide, please. So as I say, it's a principled approach. We have enlisted a set of principles, and the reason why we have come up with each step is supported by a set of principles. And I'm sorry about the background noise. Please ignore my daughter. Next slide, please. So the previous slide. So the first step is previous to that. Yes, thank you very much. So we start with domain footprint, slide number 12. Thank you. Where we have participants, particularly from Cardiff University. They were divided in groups and they were given scenarios, and they were asked to enlist as many questions as possible based on those scenarios, like what would be the dishes they order in restaurants, food they cook at home, what would be the food and drinks ordered online, their monthly expenditure, just to get an idea of different so-called ethnographic aspects, the culture, religion, what is their monthly income, and how do they influence their food intake. Next slide, please. So the next step is knowledge acquisition, which involves in identifying terms relevant to the domain. So we came up, we saw that food cooked at home, they would cook halal food, vegan food, they would take cheese and wine. So this type of information provided some understanding of their background, religion, dietary choices, restaurants visited, their health constraints, what would be their online search typically. So as you can see, they search for typical antipasti with prawn, tomato, and basil. So if we have in the group an Italian friend, a colleague, they will understand immediately that there is an origin in common. So what we did, we collected the terms like halal food, budget restaurant, chef, roasted turkey, antipasti, and we started. So this is the knowledge acquisition step, and we started analyzing these terms based on the principles, which I'll be explaining in a bit. Next slide, please. And so the data sources we had used, we followed, we looked into different web pages like British Nutrition Foundation and other recipe sites. Ontologies that we looked into were FoodOn, BBC Food Ontology for the care of elderly at home, chronic disease dietary consultations using ontology. Taxonomies used were Langual, AgroVoc, and also we followed WordNet and EuroWordNet as a part of the data sets. Next slide, please. So as part of the knowledge formulation process, which involved in analyzing the terms which we collected, we identified the beverage as wine, diet nutrition specific would be vegan. If the course is antipasti, then the origin would be Italy. Medical condition would be diabetic. Food choice would be chef's special. And we went ahead with the definitions and characteristics, and it was quite a rigorous approach. Can we go to the next slide, please? So considering a term, say chef, we looked into different sources that I had mentioned. WordNet, Wikipedia, Oxford, and then what we found.
Musashi, we may have lost your audio. Okay.
Is it okay?
I can hear you.
Sorry.
Now we can hear you back in 2 minutes, please.
Okay. So this was a approach of analyzing and redefining the terms. Next slide, please. So the facets that we had discovered based on terms and their characteristics identified, we followed principles like principle of helpful sequence. So the principle had several subcategories. For instance, if it is something related to principle of later in time would be the religion, that how a food came in picture as religion, different religions came in time and place. Principle of bottom-up approach. Many of the botanists will be able to understand that how we actually categorize root to fruit. Principle. So different principles were used. Principle of context, principle of consistency. When we were trying to build the facets, we had to keep these things in mind. That the categorization would be consistent and at par with the context. Next slide, please. So when it comes to term standardization, we did look into Langual. For instance, when we looked search for a term like turkey in the context of roasted turkey, Langual provided us with several concepts. Next slide, please. And the concept that we chose, which was relevant here, was prepared or processed turkey. Next slide, please.
Okay, 1 minute.
So we modeled based on the protege approach, the concepts, data properties, and relational properties, and this is just an excerpt. Next slide, please. So here we tried to formalize the concepts, individuals, hierarchical relations and properties associated to the ontology. Next slide, please. And I have defined the steps to formalize, and we evaluated. It was based on a manual evaluation by users and experts. So next slide, please. The experts were chosen from NHS. We had contacted dietitians and nutritionists, professionals from Vail University Health Board. And the users, next slide please, the potential users would be the elderly visiting Cardiff Central Library. So this is what we have in our mind, the evaluation part. Next slide. And next slide please. And as part of the future direction, what we intend to do is we want to build an app. We are working on the prototype, and of course globalize the system, go beyond UK. Thank you. Sorry, I ran out of time.
That's okay. Thank you so much. And I really enjoyed hearing a focused approach and how you're not trying to boil the ocean on such important research area, really. But thank you for your presentation. All right, everyone. This is us reaching the end of our presentations. I don't know if Tarini is here, but I wanted to give you a brief update about her experiment. I don't know if you chose to participate in her experiment and baked a delicious banana bread yourselves, but I know a number of people in the audience did. And based on her data, many of the participants already enjoyed cooking and also were motivated by healthy choices. So she's choosing to write a report on her results, and I, for one, will be looking forward to reading this report. And with that, we are going to take about a 10-minute break for coffee, and we will be back here at about 10:25 to look at our questions and discuss further about the presentations we had today. Please don't forget to add your questions to the document, and I will see you again shortly.
I'll pause recording, Andy.
Thank you, Damon. Seems like we are back. There are many questions that were written on the document. I'm not sure if we should go over them and have the speakers to give a chance to reply in person, or should we go ahead and what do you think?
Okay, so I missed it if there was a question there. How shall we proceed?
Yeah, I see some of the answers already typed in, but I was wondering if the audience would rather hear from the presenters, or how do you think we should go ahead and proceed with that? If there's any preference one way or the other.
Yeah, well, I recall it was pretty fruitful in the past to start with the questions that pitched at each presenter. And if the person is there available online to actually ask the question, then they can do it themselves. So that suggests the first up. Now, we didn't record who asked the question, so they'll have to raise their hand or speak up.
All right, sounds good. So I see the first question. I don't see a name attached to it for Dr. Horrocks. Thank you for your talk. In your method, it is needed that there already exists an ontology in this specific domain that the ontologist is working on. But in many cases, the ontology is being developed due to the lack of ontologies in the domain rather than to differences of modeling. I'm not sure if Dr. Horrocks is online. Ian, can you hear us?
Yeah, sure. Hi. Yeah, I mean, good question. I wrote my answer in line already, which is basically that actually ontologies are becoming so much more widely used these days that it's actually not so easy to find domains that you can go into ontologizing where nobody has been before. So usually there's at least something you could work with, and in the worst case you could even resort to using things like Wikidata or DBpedia, just sort of general purpose ontologies. Of course, the granular knowledge about food, say, in there is going to be much less useful, I suppose, but it might at least give you, something.
Right. I guess my follow-up would be that for a lot of the ontologies that I've come across in biontology's domain, not many axioms are present. And I think if I'm remembering correctly, your method relied on axiomatic equivalency relationships. So I'm wondering, is there any escape from that, or is there any way that you can compensate in where you have not many axioms defining the term?
Well, actually, the method doesn't assume that there exist any cross-ontology axioms. It finds them automatically using one of these alignment tools. We use LogMap, but there are a whole bunch of those kind of tools out there, so you pick your favorite, or use all of them even if you want. The more of these alignments you get, sort of the better. And in bio and life sciences, I would say this is one of the areas where there are just a huge number of ontologies with lots of overlapping. So I guess there are plenty of opportunities to try to look for alignments and use those correspondences then to do some QA on the ontology you're developing.
I see.
So one angle there is that you can apply the alignment tool to just two ontologies that have subclass distinctions, but not other object relations, and still have a result.
Yeah, which surely is sometimes very limited, right? Damien, since you're already on, would you like to ask your question following up?
Yeah, so I wasn't clear about how much push button operability there was here. I get that it's not in Protégé, but is there a script that you can run that just sort of applies both the alignment tool and then your tool?
Yeah, I'm ashamed to admit that at the moment it's really just like an appalling lash up of sort of using reasoners, mapping tools, Protégé, various kind of Linux command line tools, and God knows what. So the simple answer is no, I'm afraid not. I mean, if there's really interest in it, and if it looks like a promising technique, then, you know, we could put a bit more effort into at least trying to sort of script something. Actually producing like really usable tools like Protégé, say, that's really problematical for groups like ours who are mostly interested in sort of more theoretical research. You know, we don't have the resources or probably even the skills for doing that. So, you know, if anyone's out there and wants to take the idea and build a tool, be my guest.
It would be great to be in a position to at least be able to, if you had instructions to run the 2 or 3 tools needed, command line Linux. I'm still game. I'm in the game for that, because it would be great to have something we could iterate.
Yeah, I agree, definitely. So do you want to continue with your question related to the reasoner, or do you think that?
Yeah, let's see. Right, the hermit versus.
Yes.
I'll deal with the mushroom thing offline. One, maybe just for the audience, one distinction FoodOn was trying to make, although not particularly successfully, is the distinction between references to whole organisms, the plant or animal food source, and versus the productization of some part of or whole of that organism. And we're revising that, but suffice to say, mushroom is an example. When colloquially, when we think of mushroom as a product, it's immediately the top half, the stuff that's above the ground. Whereas the actual mushroom organism can be something that stretches between fungi, between trees in an entire forest, and weigh more than a whale. so that's the space that one of Ian's logical explorations has exposed, that we are mentioning probably some mushrooms directly under food product. So we're moving to consolidate one thing, which is the NCBI taxon organism references and the plant and animal food source that FoodOn invented stamped IDs for. We'll be trying to consolidate those, which will help. Anyway, that's just a side note. My other question was elk versus hermit. So now I understand is it the alignment tool that's choosing its kind of reasoner, or is the inferential step after that? I think it was after that, right? So would it make a difference to run elk versus hermit, or would I be basically having the same result?
I mean, it potentially could make a difference, because elk could potentially find fewer subsumption relationships than hermit does, but it would still work perfectly fine. It would, potentially find some interesting stuff. And as I said in the talk, one of the advantages of working on this kind of tool is we don't really care about completeness or even correctness. We just care about kind of narrowing down some regions that we can then feed back to the ontology developers to say, take a look at this. If it's not of interest, fine, ignore it. If it is, then you can do something about it.
Great.
Yeah, I can see how elk will be a little different myself. Yeah. Okay, well, Usashi had a question. Would you like to, how would you like to evaluate this proposed approach? I'm sure this is domain-independent approach.
Right. Yeah, I mean, this was a good question from Musashi. Obviously, one kind of weakness in this preliminary paper is that the evaluation is extremely sketchy. And yes, it should be domain independent, and ideally we'd evaluate this using several pairs of ontologies from different domains. And then I guess what you would really like to have is, you know, gold standards for correction, but that's unlikely to exist, of course, because if it was there, people would have corrected the ontology already. So probably what we would do is just feed the results back and get domain experts to say, you know, 50% of them were useful or something like that.
Mm-hmm. Yeah. Right, and that, you know, and like you said, number of ontologies also must be a factor in this, and you know, how many can you cross-reference and check with? Okay, following.
Sorry, and can I add something, Ian? Just I was wondering whether now that just prior to my question, you were saying that when you were addressing Damien's query, that this particular ontology, you are saying that, I mean, if the users are happy, then you are happy. So I mean, if they're not, if it's not working, I mean, okay, we can try some other users. So I'm wondering now whether how would you, yeah, I mean, how would you evaluate? Because you said that if it's not working for one expert, you move on to another expert.
I didn't mean to suggest that. I just meant that, you know, the only way I could, well, a way I could imagine evaluating it is just do exactly what we did in this experiment, draft in Damon here and, you know, give him the results and say, could you please tell me how many of those are, you know, good and how many are bad? And yeah, I guess if it's giving too many false results, then it will be not very useful because people like Damien will soon get sick of it and stop using it. But I didn't mean that if I didn't like the answers that he gave me, I'd just choose another expert until I can find one that says it's great.
Okay. Okay, thanks, Ian.
Okay. So I will continue with Anna Maria's question. Anna Maria, would you
one thing?
Go ahead.
Oh, never mind.
Oh. I was just wondering if Anna Maria would like to ask it herself, or would you like me to read it for you, Anna Maria? All right. I'll go ahead and give it. Oh, there she is. Hi. I don't think we can hear you, so I'm going to go ahead and read your question. In addition to cover the similar domain, do the two ontologies need to be developed using the same format, BFO or Dolce?
Yeah, I mean, not at all. Actually, I'm pretty sure that this isn't the case for FoodOn and Hellas. In fact, the design of the two is really quite radically different, but it still, you know, came up with something useful. Of course, if you had another ontology that did use the same upper level ontology or other kind of design concepts, then I suppose the results might be better. But it's not a prerequisite.
Yeah, sorry, I'm here. I think I'm back now.
Yes, you are. Hi.
Yeah, okay. No, the reason why I ask is because some of different formats can classify concept in different way. And so maybe you can lose, like you were, you know, you're saying the case of what you have aligned, the milk, the soybean milk is not the children of soybean food. And that could happen if the format is different because they may be classified in a different way following the different format. That's why I was asking if that was a requirement or if that is taken in consideration.
Yeah, I mean, you're right. You know, obviously, one of the problems here is that the sort of higher level design can potentially be radically different. But again, I just sort of fall back to my claim that, you know, I don't really care about being absolutely correct or finding all possible errors. If I can just, you know, the tool can just highlight a few things without too much noise, then it's already potentially useful. Of course, we'll never develop a tool that identifies every possible error.
And I'll just add that I'm correcting the soybean classification right now.
But yeah, I can definitely see how the subsumption hierarchy versus axioms. That's why I was bringing in the axioms. All right, I'm just going to go ahead and try to go a little faster because I want all of our presenters to answer our questions. So the next question is from Lydia. I would like to know why you choose the log map tool over the other alignment tools. Did you experiment with other tools, or if you plan to on doing so, which other tools would you start with?
Right. Yeah, I chose it primarily due to laziness. So I had it there on my laptop, so that's the one I used. And it, you know, as I said in the answer in the document, the whole framework should be pretty much agnostic with respect to reasoners and alignment tools and so on. So, you know, you can use whatever you like there and whatever works best for you. And yeah, there's probably better tools out there than LogMap, but I was just in the business of, you know, proof of concept.
I understand. Okay, I think the microphone is broken, so I don't know if there's any follow-up. We'll move on to thank you very much, Dr. Horrocks, for your answers, and I'm sure he'll be available to contact offline if you have further questions. And I will move on to Patrice's presentation and new alignment methods based on FoodOn. I think, Damien, if you could get us started, we can take it from there.
Okay, I was just looking at, just a sec. Oh, right, yeah, so I couldn't recall from previous presentations. SQL is a French food database, so I know they have croissant and other French foods as well as cornflakes. And that Languel matching covers part of the algorithm, but the other part did involve label stuff. So was FoodOn coming up short in terms of helping out on the label matching for food products?
Thank you for the question. Yes, in fact, in most of FCDBs we have studied, we have English labels associated to food products. Therefore, it will work with most of those FCDBs. I think it is not a big barrier. And what I could mention is more on the techniques we use for lexical matching. For the moment, it was the first version of our methods, and we implemented a very quite simple lexical matching. It's simply a cosine similarity between a set of lemmatized words when we compared the two terms. And it should. We think that we can obviously we can optimize it with more advanced string comparison matching techniques. Therefore, my answer is more to look after more optimized comparison string matching methods. It's not necessary to add new information in FoodOn like French labels, things like that, for instance.
Mm-hmm. Okay.
Moving on, question from Alessandra. I don't know if she wants to ask it herself, but she asked about the linkage between FoodOn and FoodX2. Do you have any preliminary studies, I think is what she meant. This question came during your presentation.
Yes, thank you for this second question. In fact, what we did exactly is to map on the siren subpart of FoodOn, because all the food terms, food concept in this part are all described in Languel. And we took also advantage of the fact that a lot of agencies have described their own vocabulary in Langual. It is available in the URL I put in the chat. Of course, the new question is that in Europe, we have to deal with FoodX2, a standardized vocabulary, which is the vocabulary which must be used by European food agencies now. And I think that some resources exist which permit to map Langual to FoodX2. Therefore, we have to make some studies about that in order to see if we can adapt our method, taking into account this mapping between between Langual and FoodX2. Excuse me.
If I could add, Langual, the latest version of Langual has a whole product facet, categorization facet for FoodX2's exposure vocabulary, as I recall. And we have brought that facet into FoodOn with its whole hierarchy of 4,000 codes or so. And our also an upcoming objective is to ensure that each of those matches to a FoodOn native food category. And so we'll benefit from any mapping work that's already been done in that regard.
Okay.
Thank you both. And another question is about combining the two similarity measures from Alrick Oudot, perhaps. In your presentation, you mentioned about the similarity measures you use. I think he wants to know if you know about combining the two different ones.
Yep. In fact, in our current implementation, it's also very simple. We only make the mean of the two similarity measures. We have tried some other simple aggregation function like max function, but it was not successful. Okay, we are open to any suggestion. Okay, if you have any idea, we're interested in, of course.
And there are many ways to define similarity. Yeah. So the last question for you is from Ian, and I don't know if you would like to ask it yourself, Ian.
Sure, why not? Yeah, thanks for the interesting talk. And I was just wondering about if you considered transforming the sources into graphs or ontologies, or possibly they already are graphs or ontologies, and using other alignment techniques aimed at graphs and ontologies, because there's a lot of work going on in that space at the moment that you could potentially take advantage of.
Yes, thank you for your question. Of course, it is a very interesting suggestion. And for the moment, the work we have presented here is the result of collaboration with some industrial partners. Therefore, the first effort was to understand what they need first, and to see how we can answer, how we can propose solutions. Therefore, the knowledge resources we used are not available in as ontologies, but we have proposed a translation into all of the FCDB vocabularies associated with Langual description. Of course, our objective is to be able to propose a use case to in a future OAEI challenge to get feedback from people who are interested in alignment methods.
Thank you so much. I think that will be very interesting to see how the graphs would play a role in this. Okay, so I'll go ahead and continue with Liliana. And the first question is again from Damien. So he asked about food industry processing is quite detailed depending on machinery. To model the processing of your selected foods, did you have an adequate set of food transformation processes from FoodOn, or did you need to add new processes for particular kinds of equipment?
I will start with a short answer, and then I will let Magalie to complete, because she's in charge with this task. So we have our project is a use case. We have a very specific itinerary about sausage making, and it is very, very precise. And when Magalie tried to represent it in using a concept from FoodOn, we discovered that the way to cut meat is different between Europe and even between different country in Europe. So Magalie is working on this in a working group with Damien. So I let her explain how we managed to add some new processes and new materials concerning this very, very specific use case.
Magalie, there she is.
Hi, can you hear me? Yes?
Yes, we can.
Thank you for your question, Damien. Yes, as Liliana said, we have a specific use case, so we only have to add a very few numbers of equipment so far, but it would be very interesting to complete this work and by the way, to know the name of the Cornell project you mentioned. I think this contact will be very useful because indeed we had to complete the list of equipments and materials associated with food transformation process on a wider range of processes. In our department, food research department at INRAE, we are interested in food and bioproducts and also waste transformation. So I think there is a lot of work to be done.
Okay.
Thank you for your nice help on all the ontologies issues.
Right. Well, this particular case actually illustrates the whole reason for the Integrated Food Ontology Workshop, because the Cornell people are actually, the whole department is focused around food safety, and they are sampling machinery inside and out, up the yin yang, and they need the vocabulary to identify exactly where they're doing their samples on walls with swabs, different kinds of sampling techniques. And it turns out that interest aligns perfectly, I think, with your own interest to describe the very same equipment. They need a loose understanding of what the equipment is doing. They want that descriptive there, but they need the names of the equipment. So there's this kind of a natural harmony between your two projects. And that's what I like to see coming out of this whole IFO effort.
Great, great. Yes, I know surface is cleaning and so on. You mean it's great.
I think it's really great that if we can synergize some of that efforts coming together, I think that would be super and perfect. I'm also wondering if you think Liliana or anybody else in the group can we find perhaps a minimal information kind of a minimal model, if you were, that we can add on to as needed, and we can also maintain that so that we can use these ontologies together and help them feed each other information.
I can start with an answer and the other may complete. I think that our proposal to build this, what we call a PO2 ontology, it's our effort to have a very kind of unified, very high level view, because if you try to come to each domain, you will be in a very, very detailed description. For instance, if you want to build sausage, you are interested in some kind of material, we will have detailed what kind of pork meat you will need, if it's the swine or the other one. So in industry, apparently it's very important. And if the same composition is in Europe, it would be not the same for the same industrial partner in the United States, that the recipe will not be the same. So if you want really to came to the very little detail, you will be lost. So I think you need some kind of this is our proposal to be a little to lift a little bit, but maybe they will need another intermediate level to aggregate information. Otherwise, it's awful. This is my my point of view. Maybe the others want to comment.
I agree with your point of view, but I welcome if anybody has any other comments or experience in doing this, or any suggestions or follow-up questions. This is very interesting to me, and thank you very much for your answer, Liliana. I will, if there are no other questions or comments, I will go ahead and move on to the next presentation from Gurinder Gosal. I hope I'm not butchering your name. And the first question is from Usashi. And she's asking, you referring to the high level architecture, could you please elaborate on ontology refinement process?
Thanks, Usashi, for your question. I think at that particular slide, you are actually referring to the ontology-driven classification refinement process, not the ontology refinement process, because the tool doesn't do any ontology refinement. So in the case of the classification refinement, of course, we have the refinement rules, which are according to the requirements of the third party, what they want with the categories. So two examples I have given here is, for example, there is a original classified class is clinical research, and there is some animal class also involved in that. That is a veterinary animal class, for example. Then we, the refinement rule actually does is to convert that class category or classification to the veterinary clinical research. That case. Or there can be another example, like if there are more than one food ingredient is involved, and then we add the multi-ingredient to the classification results in that case. So there are many refinement rules like that. So catering to the needs of the third party, how they want those things to be classified. And if you ask about the LexMapper's contribution towards the refinement in the ontology, what I can say is reporting the missing terms. When we run the LexMapper, then we found so many missing terms which are not there in the ontology. So that is for the ontology custodians actually to curate, and if they want to include that, they can include that. So I think FoodOn owes more than 1,000 terms to LexMapper. Those 1,000 terms are in FoodOn because of the LexMapper, because it found and reported those missing terms from the real data set. So have I answered your question, Sasa?
Yeah. Okay. Thank you for the elaborate explanation. Thank you so much, Gurinder. Appreciate it.
Is anybody else? I think, thank you, Gurinder. And I see that you also provided a link to the documents for your next question. So I actually, I'm wondering, just out of curiosity, if you ever try to look at ontologies across domains when you were looking at your rules. Did you ever try to, go ahead.
Yeah, you mean going beyond the FoodOn and GenAP ontologies?
Yes.
Yeah, we are doing that. That's in my one of the slides. I mentioned that. So all these things are now customizable. You can select user-defined, means user-selected ontologies. So we are doing it for multiple projects actually. Like one.
Yeah, I remember you said the COVID project and all of that, but yeah, I was just, yeah, I guess.
Yeah, we can do that. Like we can select.
I see.
And we can also customize the other things, like the lookup tables, because those are very domain specific. So you have different abbreviations, for example, in a one particular domain, and you can't have a generalized abbreviation lookup table because people use same abbreviation in different domains for different things, right? So,
yes, yeah.
So, yeah. So it is there, like the tutorial is there, like how to customize those things, and people can go through that.
Okay. All right. Well, that's certainly very interesting. You have a comment, Damien?
Just that normally LexMapper is available online, but we're switching servers as we're moving our facilities, so it's not available at the moment.
Okay. Right. Thank you for that. Are there any other questions or comments from the audience? Okay. I will move on then to the thank you again, Grunder. And I think I had a question for Sashi. I was wondering if you got a chance to look at the chemical compositions of some of the foods that you mentioned in your presentation, and then try and see if the active drug ingredients had anything to do with some of these chemicals in foods.
This is definitely one direction, and as I have written, we are missing an expert in this particular field of bioscientists, biochemical or food science experts who have knowledge on the chemical composition and drug aspect. And this is key, as I understand, because there are triggers that influence such chronic illness and mental disease like depression. And one idea is to contact medical practitioners, doctors who are there in Wales or Heath Hospital. And also I look forward to collaboration and working with the colleagues here who have expertise in this domain. So yeah, looking forward to suggestions.
That is good to hear, and that's interesting. Because I remember in one of the earlier sessions there was a presentation about drug side effects in food, and so I was just wondering if there. And I've seen presentations where Kebi is used, where you can find some of these chemicals and related information. So I was just wondering if we get a chance to look at it. And thank you very much for your answer. I really appreciate it. And
thank you.
Any other questions or comments from the audience? Okay.
One thing I know is that from the Monarch group, they have a Maxo ontology that they're trying to bring together different terms from different ontologies, including dietary terms. That's one reason we started working with IFO to develop dietary terms for ONS. And their job is to look for genetic and phenotype connections. And so I believe their tool, their ontology, is targeted towards searching for papers that can see disease-related effects based on diet. So I presume, Musashi, that that kind of work will be helpful for you guys too.
Okay, thanks for your suggestion, Daniel. Mm-hmm.
That's really great. All right. Well, I do have some general questions to our presenters, and I would love to hear opinions from all our presenters if possible. So I will start from the end this time. The one question is, what are the presenters' preferred inference or software for grouping or assigning parent names or preferred descriptors from Ahuja, maybe? I don't know if you would like to speak up and ask your question and elaborate on that. Right. Is there, Usashi, would you like to start? You were the first one to end. If you have any recommendations, I think that'll be useful for the audience to hear.
Sorry, Handy, I need some time as I went back to Damien's suggestion and I started working on it. I'm so sorry. I'll get back to you guys in a bit if that is okay.
Okay. Well, is there any of our presenters who are ready to answer? And I'll give you some time to, and the question is once more, what is the preferred interface or software for grouping or assigning parent names or preferred descriptors for terms, I assume? And I think that's an important discussion point. And we've discussed with several groups kind of a place like an ontology marketplace of sorts, and where you can shop for ontologies, as it were, and see how ontologies are evolving. And I know that there's some effort in the Obo Foundry, OBI, and others for that kind of help. That's my knowledge. I don't know if there's any tools or software. Our presenters, if you'd like to jump in and fill in, I would appreciate that.
I have to say, I'm not quite sure about the question. Might have to define the question a little bit more. If the questioner is online still.
Yeah, Damon, this is Jaspreet and Jaspreet Ahuja from USDA. And excuse me, I'm very new to this whole field, so I probably don't have the right terminology. But, you know, speaking from what I have, so we've been, just to give a background as where I'm coming from, is we've been looking at ingredients as listed on the labels, which are, you know, extremely untidy and, you know, and very inconsistent. So, and then we've been trying to give them a parent name or preferred descriptor, which is more, you know, which is what you would find in ontologies and different classification systems. So this process of assigning, you know, and we use some of the existing systems like the FDA system and NALT, USDA's National Agriculture Libraries. So the ones that are there, but you know, none of these, like for general food, nobody is gonna have the kind of terms that we are seeing on the ingredient statements. So this is kind of a bridge from what's in the commercial ingredient listings to, you know, to the real terms, you know, real food terms. So for that, we ended up doing a lot of that manual, which doesn't seem like the best way to do it. And I was kind of trying to write on the experience of all these people over here to find out how, you know, they may have a different domain, but what are they using for similar kind of tasks?
I'll just frame that. It's really a text to ontology mapping challenge.
Yeah.
And on the ontology side, we have the responsibility of having the terms to match to. And Gurinder maybe can talk to this a bit. One of our primary objectives was to be able, with LexMapper, was to be able to map short textual and descriptions of food to ontology terms to match, and that's in the food product space. So the ingredient list, I believe, covers food products, but also things like salt and iodine and other things that you get into sometimes pretty technical food additive names and so on are showing up. So I presume that's kind of the challenge, as well as all of the linguistics that show up in the database around misspellings, plurality, and synonyms.
Right. And I don't know if any of our presenters have any recommendations of tools. And like Damien said, there is a cross ontology need for this kind of problem, I think, where we can find many ontologies that are in the same domain, maybe looking at similar vocabulary together so that we can decide which one of the options is most suitable. Is that something that might be helpful? Just if one were to create something similar to what you're looking for.
I could say something.
Absolutely, please.
Yeah, I mean, obviously this, as you're saying, is like a really widespread problem, how to go from relatively informally expressed knowledge to something more structured and hopefully aligned with an ontology. But what I would say is that there's, you know, again, a vast amount of work out there addressing similar problems. I mean, for example, the problem of taking information in knowledge graphs where some of the nodes in the graph are just expressed as strings rather than really entity references to other nodes. That's a well-known problem called canonicalization. And there's a lot of work out there that, you know, employs a variety of NLP and learning techniques to try to do that. And, you know, you could view your ingredients list on a particular product as a sort of mini ontology, and then, you know, try to use some kind of learning and alignment techniques to align that with FoodOn or, you know, some other suitable ontology. So basically what I would say is, as a kind of, you know, a higher level comment is, I don't know specific tools, but, you know, look at the myriad of tools and techniques that are out there, and the huge amount of work that's going on in this general area now with kind of graph embeddings and who knows what all else, and try to sort of frame your problem in terms of what some of those guys are trying to do, and then exploit the tools that they're developing for you. Then you don't have to do everything yourself.
One of the keywords there in the field is named entity recognition, NER.
Yeah, and I guess there's a huge amount of work on that as well that you would tap into. But I mean, in this particular case, I guess that it makes sense not to do it on a kind of ingredient by ingredient basis, but try to exploit the fact that, you know, all of those ingredients are ingredients of a given kind of product, you know, which gives you some extra, more structured information that you could then, you know, give some sort of graph learning process a bit more to get hold of. So the more you can exploit the structure you have, the better.
I'll just put in a little thing, which is in FoodOn, we are really trying to cover all the synonyms, because synonymy is one of the big problems in that ingredient recognition. So one of our objectives is to try to cover all the synonyms that you might end up needing to map to a particular ingredient.
There's a big and challenging problem. I'm so glad to hear that there's effort towards that. Or do any of the other presenters want to chime in before we move on to the last question?
Could I just add on? There are some nice YouTube tutorials by the Stanford NLP group, which I had followed, and I had used them to extract ingredients from recipes. So having an unstructured text, following some simple shell programming, I could extract the ingredients and then build an ontology out of those. So maybe that can be useful. One could explore that part.
Very helpful, thank you, Isashi. Any other comments?
If this is Jaspreet again, it would be really nice if Isashi, you can forward that link.
I will just give me some time. I'll send you the link.
Thank you so much.
No problem.
Thank you, everyone. Appreciate your inputs.
Thank you for your question, Jaspreet. And Sashi, if you want to put the link in the question document, that might be helpful for the whole audience. If you could.
No problem.
Thank you. Okay. The final question for this session is, while there are academic and perhaps proprietary reasons to develop and explore different approaches, but from a practical standpoint, are there efforts to truly harmonize and align vocabularies and ontologies across the different domains? Great example was the example of different names for trucks in different parts of the country in the world. From biomedical, chemical, food, ag worlds, what is the component or nutrient? Can machine learning and artificial intelligence be used to hasten the progress? The person who's asked the question can speak up and clarify. I mean, it's clear, but if you want to elaborate more on it, you're welcome to. I don't have a name on the document, but I think that's an interesting question, and I, for one, would very much like to see such harmonization and collaboration.
So this is Naomi Fukugawa. I'm the one who wrote that question.
Hi.
And that's because throughout several of today's presentations and over the last few weeks, we've heard the term component used. We've used the term nutrient, but different people use it differently. So for example, today's presentation, component meant an ingredient. And what is an ingredient versus a component? Because from a chemical standpoint, a component may be the chemical compound that is in a food that may induce the biological effect. And I think considering that this is a rapidly evolving field, from a practical standpoint, I think it's really quite important as food, agriculture, health, and other concerns about food safety, etc., is hitting the forefront of why we need to be a little more harmonized, despite what our individual countries may be saying. Is it possible that one could find a way to perhaps bridge much of it? I know a lot of these efforts are, everyone's trying to be bridging it, but from an academic point of view, a lot of times developing your own approach, may lead you down to job security as well as tenure or something like that. But, the world of needing to get things to move on and work for the great good, I would hope that there might be a way. I don't know how to do it, and that's why I thought the computers might be able to do it for us.
Can I jump in on this one?
Of course, go ahead. Thank you, Naomi.
I agree with Naomi. However, one of the lessons that I've learned in the past couple of years is that if you're in your own specialty, you're capable of defining what you actually mean in the term, you're way ahead of everybody else. And I know that sounds a little bit cynical, but the truth is, just if you know what you're talking about or trying to talk about, then it gives you a reference point in order to which to compare and link to other people. And the truth is, in the majority of cases, people are just not there.
Right. So, I guess, and that's why I think we're trying to employ, I'm not an ontologist, just to make it very clear, but, to try to employ these approaches to help make the connections between the expertise in different areas, and I thought, the fact of the trucks was a great example, but it's similar in terms of how one might describe a food product or a chemical or whatever. And I guess that's what hierarchies are all about. But, I don't know what the answer is.
Yes, go ahead. No, I was just going to say I have some comments, but I really want to hear from our presenters as well if they have any comments. So go ahead, Damien. I think I interrupted you.
Well, no, man. I think maybe, yeah. Let's throw it out to the floor. I do have some comments too. But...
All right. We'll hold our tongues for now. Okay. And do any of the people in the audience or do any of our presenters have a comment?
Well, I guess I should say that I'm not seeking a specific answer, but maybe, sort of getting an idea of where we could start to begin.
Right.
You know, in a sense, we're doing it, you know, with FoodOn for the USDA food composition data system, but then we've since learned that there's so many other ontologies that we somehow have to work into. And, you know, thinking about food processing, preparations, recipes, and so forth. I just am totally boggled as to how one even starts.
Right. And one of the things that we've actually experienced with in the bioassay realm is trying to use these different ontologies together to annotate even readable text. We've actually come across ways we were able to employ some machine learning ways to help with the process of determining what can be actually correlating to something else, and can we create some rules based on that, and there is progress towards that kind of a thing. And we've actually, like I said, it's very domain specific, it's in the bioassay realm, but conceptually it is, I think it is possible. I've seen it happen, but I'm wondering if there are any other ways that anybody else tried in their work, or seen it as a purely academic study.
Can I just make a comment, please?
Absolutely.
It's Liliana. So I'm a computer scientist, that's as a background, and I work in different domains, in chemistry a little bit, in food safety a few years ago, and now in food transformation. And the problem I see is that, okay, for the truck, it was very simple to everyone to see that there are different ways of naming the trucks. And it's obvious for normal people to see this, but for a computer scientist and ontologist, I think it's very, very complicated. You need years of experience to understand that the very specific term in a very specific domain. We worked with experts in sensing sensitivity, the taste and aroma, flavors and things like this. I didn't understand the very precise way they defined it. So I don't have the answer. I think we need to work together more to try to find an agreement and to better define every way you use terms. And sometimes it's exactly the same. But if you use it in a chemistry domain, it will mean something. If you use it in a study concerning food analysis or risk analysis, it will be something else. So I don't have the answer, but I know it's a very complicated problem.
So I'd like to say, I think the great thing that ontology allows is terms in an ontology that have different definitions, and that you can reflect that a bit, that change in sense in the label, so that people can understand that diet doesn't just mean one thing to one person and something else to someone else. And I'll just say the whole reason the IFO Integrated Food Ontology Work Group, as opposed to the workshop. This is the workshop. There's a work group that we started up this spring around diet terms, because diet was a classic example of a term that had different semantics for different people, including some of us like me who are kind of ignorant of the nuance. So I'm just going to screen share the results of that process, which is that we started realizing there are different senses of diet, and each of them gets a label and its sense of definition. So we're not stuck in an ontology with just one term called diet. We get to break it down and reflect the different senses in the label. So I feel like this is one key basic step that gift that the ontology folks can offer other professions. Say, we can bring in your senses and have them all under one roof, so that we can compare diet by food organism, and the kind of thing that you're eating or diet by a prescriptive diet, and so on. So this hashing through these definitions has occurred through a multidisciplinary group of people from different sectors. So a lot of nutritionist input, but I expect to see the same kind of process happen with other groups around terms that are semantically seem similar but have variance.
Right. Thank you for sharing this, Damien. This is very interesting. And yeah, I can absolutely see how it can get out of hand. Like Liliana said, this can get very complicated and out of hand very quickly. I'm wondering if anyone else had any success by being a little ignorant of the different voices and deciding perhaps in a very undiplomatic way to say, okay, this is the data set that I'm going to deal with, and this is the set of terms that I'm going to deal with, and then let me see if computers can help me. Is there any experience like that from anyone in the audience?
Where there's one aspect of that, like, and I'm sorry, I'm going to jump on my soapbox again. If just knowing what you're talking about does not mean that you're right, but at least everyone knows where you stand.
That's true. Yes.
And if you can derive your terms from an authoritative source, and let's, for example, use regulations or laws, which are not necessarily right, but they are right according to a certain standards, you're ahead of everyone else because we know where you stand. And the value to if you use standards such as OWL, one of the things that you can state categorically is you disagree with someone by stating OWL different from. And there are a number of ontological tools that you can use to differentiate yourself from other people by saying that I mean this, but I don't mean that. And that's a way to build yourself to a certain truth by saying I disagree with these people. I think that in many cases, disagreement is what builds the agreement.
Yeah.
You know, that's a very good philosophical point of how we should approach it. And I think the people that I've sort of encountered in this field seem to be willing to do that much more than some of the more established fields that exist in science. So there is hope.
Really clear.
So
yeah, it reminds me of sort of there's the vocabulary used in science, and then there's the vocabulary used within regulatory worlds.
Right.
So tomato, vegetable, fruit, that kind of thing. So, but I do still put a plug in. You can actually just differentiate your labels, classes, fruit regulatory, fruit biological, that kind of thing within one ontology. But I like your point, Warren.
Yeah. And all right. Well, we have 2 minutes left. I don't know, Damien, if you want to wrap it up. Thank you again for this question, Naomi. And I think that everyone will keep thinking about this. I know I will. So I don't know if you want to have a brief closing message for us, Damien. Thank you, everyone, for being such an engaging audience today. I appreciate it. And thank you to the organizing committee for this multifaceted workshop. This was really good.
Yes, and thank you, Handy, for hosting. Well done. And to the whole audience that's come in to this, it's been great in the last 4 weeks. And just to say that the proceedings, for the most part, will be available on the Integrated Food Ontology Work Group GitHub repo. And as well, all of this happened, of course, virtually. We were all supposed to be sitting in Bolzano, enjoying the mountains and discussing our problems there. I believe the intention is for us to make it real next year, and that same folks can all be invited to come in and pitch the presentation. What will be really fascinating to see how the work has progressed a year into it all. And then as well, we'll have a little bit more of a focus on conference proceedings and getting the material published. This time we kind of avoided that level, partly because it's all new. This is all congealing as an integrated scene, and I'm really appreciating everybody coming in together to create this this unified landscape of food. So thank you all for helping out and supporting this. And we'll see you next year.
Thank you, Damien.
Thank you.
And everyone.
Thank you, Damien, and all the
Thank you.
organizers.
Thank you, everyone.
Bye, everyone. Enjoy the rest of your day.
Thanks, Andy. Damien was great.
Thank you.
Good. All right.